So, Vero's question, if iron is so influential in the development of chronic disease, chronic inflammation, what about iron medicine from a prescription by the doctor for things like iron deficient anemia? So, there's a lot to this, and a lot of this flies in the face of what we've been conditioned to think about ferritin and anemia. So, even if your bullshit alarm starts to, go off, stick with me and just hear what I have to say. I think 99% of all iron deficient anemia diagnoses are flat out wrong. Ferritin is an intracellular protein, which means it belongs inside the cell. That is where its job is to bind iron and prevent it from causing any unnecessary oxidative stress. And no one in the research community can give a satisfactory answer as to why serum ferritin, which belongs inside the cell, is in circulation at all in the first place. For starters, serum ferritin is not doing what intracellular ferritin does. So when ferritin's inside the cell, it can store massive amounts of iron. I think like up to 4,500 molecules of iron at one time. That capacity plummets when it enters into circulation. And when ferritin is in circulation, it's acting as an iron scavenger and acts as an acute phase reactant, eliciting inflammatory signaling. So all of that serum ferritin in your blood is giving off these little messages of, hey, something's not right, inflammation, inflammation. So if serum ferritin is actually iron poor and doesn't bind iron effectively, what's it doing there? Then it would help to get familiar with the mechanisms of ferroptosis, which is cell death initiated by iron-induced oxidation. Over this shoulder, you can see iron entering the cell and reacting with H2O2, which is hydrogen peroxide. This is a typical byproduct of normal metabolic function. It's a reactive oxygen species, but albeit a relatively neutral one. Through the Fenton and Haber-Weiss reactions, it makes this relatively inert ROS into something very reactive. This OH here is a hydroxyl radical. This hydroxyl radical migrates to the lipid membrane, the cell membrane, oxidizes polyunsaturated fatty acids within the cell membrane, and leads through this whole cascade, which ultimately ends with a hole in the cell membrane that is one of the primary signals to the cell that it needs to die off. And when that cell membrane is broken, guess what happens to everything inside the cell? It gets spilled into circulation. Thus, how intracellular ferritin gets into circulation. It's a passive sign of cell death and inflammation. So serum ferritin is a marker of iron-induced oxidative stress, not a sign of useful storage of iron or transporting iron throughout the body. That's transferrin's job, not serum ferritin. So with all of this serum ferritin in circulation, if you've been told you have anemia, which is low serum ferritin, you might be asking yourself, how would this apply to me at all? And that's because our cells have a very unique iron hiding mechanism in a state of inflammation. So as we learned in the ferroptosis pathway, iron is able to magnify the oxidative stress of the circulating reactive oxygen species. So iron reacts with this relatively neutral, inert hydrogen peroxide and turns it into this feral, volatile, and extremely reactive hydroxyl radical. And our body knows that. So in states of inflammation, no matter how it comes about, it could be pathogens, it could be bacteria, it could be a physical injury. If there are high levels of ROS within the body, indicative of inflammation, our body knows to take whatever iron is in circulation and pull it into the cell to prevent it from making whatever inflammation is out in circulation worse. And in theory, this is incredibly useful because if there's a pathogenic invasion like a parasite, a bacteria, a virus, they need iron to survive within the body. So it's like starving out the invader. And as an act of self-preservation, it's preventing iron as a fuel from fueling an already existing inflammatory state. However, if that initial inflammatory injury is iron induced, that iron hiding mechanism, which pulls iron into the cell out of circulation, is actually just feeding the problem. It's pulling iron into the cell where it's just going to oxidize further and make that ferritin cycle even worse, all the while creating a false positive for anemia, because you're going to go get your blood tested. There's not going to be any ferritin there because it's been pulled into the cell to avoid it from making the existing inflammation worse. So, in essence, taking iron from your doctor as a supplement, as a prescription, whatever, is the equivalent of trying to put out a house fire with gasoline. In order to address the underlying issue of why your iron is being mismanaged in the first place, has to do with the supporting nutrients that make sure that iron does what it's supposed to do and has a chaperone wherever it is to prevent any pre-existing inflammation from getting worse. Things like magnesium, things like copper, trace minerals, fat-soluble vitamins A, D, E, and K. I can all but guarantee when you start to focus on those supporting nutrients, your inflammatory conditions get better. And for those of you still watching this, thank you. This is at the root of, I would argue, almost all chronic disease and chronic inflammation. And it can be addressed at its root by making sure that you have adequate vitamins and minerals to manage that iron.